Now I need to introduce you to the modulus, which looks like this. So it's these two straight lines. What does it mean? So if I have the modulus of plus 2 there, then it equals 2. If I have the modulus of minus 2, then that also equals just 2. So the modulus is about the same size number, but taking away the sign of it. Now, if the number is positive already, then of course the modulus of x is equal to x. However, if x was a negative number to start with, then the modulus of x is minus x. If we look at the previous example, so the modulus of minus 2 is minus 2, and therefore it becomes plus 2. Now the modulus also works with functions. So again, if the function of x is positive, then the modulus of f of x is the same as f of x. However, if the function itself was less than 0, then the modulus of f of x is minus f of x. Here's an example. So let's say that f of x was 4x squared minus 2. So we need to know when that function is positive as a result and when it's negative. So we need to solve it. So we've got 4x squared minus 2 equals 0. So that leads to x squared equals a half, and x is either plus or minus 1 over root 2. These are the points where it crosses the x-axis. So that is the point at which it turns from being positive to negative. So f of x will be positive or 0 when x is less than or equal to minus 1 over root 2, or when x is greater than or equal to 1 over root 2. So in that situation, the modulus of f of x will equal 4x squared minus 2. Whereas f of x is negative in between minus 1 over root 2 and 1 over root 2. So in that region, the modulus of f of x will actually have the equation 2 minus 4x squared, which is the negative version of the one above. So the modulus of f of x is different to f of the modulus of x. So the modulus of f of x means work out what f of x is and then make the answer positive, whereas f of the modulus of x means make x positive first, then work out what f of x might be, which means that the function might actually end up having a negative value. So if this is a picture of our f of x, then the graph of the modulus of f of x will look like this. And what you can see is that you've got a reflection of the negative part of the original graph in the x-axis. And then if we look at the graph of f of the modulus of x, what we can see has happened there is that the part to the right-hand side of the y-axis has been reflected in the y-axis. So you might be asked to solve equations of the format modulus of f of x equals n, where n is just a number, or modulus of f of x equals g of x, so a function of x. In both cases, the first thing you need to do is sketch both functions so that you can see where they intersect with the x-axis and with each other. That will really help you later on. Now we need to solve f of x equals n or g of x, whichever version you've got, in the interval where f of x is greater than or equal to 0. So you can use your sketch to help you work that out, but you will actually need to calculate that algebraically to be more precise. Once you've solved that, you're going to check that the answers you've received actually lie in the interval. Next, you're going to solve the negative version of the function equal to n or g of x in the interval where f of x is less than 0. And again, at the end, you need to check that the answers lie in the interval. So let's say that we've been asked to solve the modulus of x squared minus 2x minus 8 equals 3. So the first thing we need to do is sketch it. And to sketch it, we need to know where it crosses the axis. So y equals x squared minus 2x minus 8 crosses the y-axis when x is 0, so that's when y equals minus 8. And when y equals 0, it crosses the x-axis, and if you factorise that, you'll find that it crosses the x-axis at 4 and minus 2. So I've drawn that in. You also need to mark on y equals 3, which is the line which corresponds to the right hand side of our equation that we've been asked to solve. So f of x is greater than or equal to 0 when x is either less than or equal to minus 2 or greater than or equal to 4. So x squared minus 2x minus 8 equals 3 will lead to x squared minus 2x minus 11 equals 0. And then using the quadratic formula, you'll find that x equals 4.46 or minus 2.46. So now we need to check that they fit in those regions that we've had. So 4.46 is greater than 4, so that's okay. And minus 2.46 is less than minus 2, so that one works. And now we're going to solve f of x in the region where it's less than 0, and this is between minus 2 and 4. So we want the negative version of the function. So that's minus x squared plus 2x plus 8 equals 3. And rearranging all of that to make it equal 0, we get x squared minus 2x minus 5. Again, use the quadratic formula and you'll find you get x equals 3.45 or minus 1.45. So the 3.45 is within the range. It's between minus 2 and 4, and so is the minus 1.45. Now let's have a go at doing one where we've got a function on the other side. So we're going to solve the modulus of x squared plus 5x plus 4 equals 2x plus 3. Again, we're going to need to sketch it. So we've got y equals x squared plus 5x plus 4. When x equals 0, y equals 4. When y equals 0, a bit of factorising will show you that x equals either minus 4 or minus 1. So I'll draw that on. Now we need to do the same for the other side. So when y equals 2x plus 3, x equals 0, y equals 3, y equals 0, we get x equals minus 3/2. So first we're going to solve x squared plus 5x plus 4 equals 2x plus 3 in the region where that function is positive, and that's when x is greater than or equal to minus 1 or less than or equal to minus 4. So rearranging, we get x squared plus 3x plus 1 equals 0. And that leads to x equals minus 0.38 or minus 2.62. So now we need to check that they fit the region. So we've got minus 0.38. That's greater than minus 1, so that's okay. Minus 2.62, however, is not less than minus 4 and it's not greater than minus 1, so that's not valid. Now we're going to solve the negative version, but you'll notice I've been a bit cunning this time. It's often easier to just make the right hand side negative rather than changing the left hand side. It all comes to the same thing eventually. So we've got x squared plus 5x plus 4 equals minus 2x minus 3. And that happens when x lies between minus 4 and minus 1, because that's where it's negative. So we've got x squared plus 7x plus 7 equals 0 when we tidy that all up. And that leads to x equals minus 1.21 or minus 5.79. So let's check them out. So minus 1.21, that does lie in the region, but minus 5.79 is less than minus 4, so it doesn't fit the region.